Hi, this is Thomas Jaeger, and today I wanted to show you the walk through the source code for Object Persistence Part 3. And you can get the source code on GitHub. I just published it, and you can get it under this address. And I'll also go ahead and post that so you don't have to write it down right now. I'll intend to update the solution over time, possibly changing the domain model, the persistence providers. I will probably add a few more persistence providers, such as a persistence provider for Redis, a NoSQL solution possibly, such as the Amazon AWS SimpleDB. It's a NoSQL database that Amazon provides. And also, of course, the traditional SQL Server solution as a provider. So you can see maybe what the differences are between those different providers and how this will work throughout the entire system inside the solution. All right, so if you go ahead and download the source code, you can either use your local GitHub client. If you have Visual Studio 2012, I think update 2 or 3 you might need, and it has full Git support. You can get it also through NuGet. I'm sorry, not NuGet, but there's a link which I don't have here to update the Visual Studios to support Git. If you don't have Visual Studio Git support, you can always get on GitHub and download here the zip file itself and then use it that way. And so, as I said, this is the continuation of part 3. I guess you can call it part 4. And I wanted to create this video and guide you through the solution instead of writing a very lengthy blog post. I think this will be a little bit easier to understand this way from an architectural point of view and what are the important components and pieces inside the solution. So let's go ahead and take a look at the actual source code. Hopefully you'll be able to see this. All right, so on the right side, you can see the solution itself. So we have the, so I created a server piece here that you see right over here, and the client part. The server part really right now consists only of 3 major components, which is the most important part would be the domain model. This is where you would house your business logic, all business rules, and possibly workflows at a later point when you're ready to extend your software solution maybe to a much more complex workflow process and how you would handle these. But from now, this is a simple domain model, which are very, very simple classes. I only have 2 classes in here right now, and I'll go that in a little bit later. Then, of course, I have the persistence itself. These are modeled based on a persistence provider pattern that's available in .NET since version 2 of the framework. I'll go that in a little bit in a little more detail. And then there's the services part. Right now I have only created a REST-based service that's built upon Web API part 2 or Web API second iteration, I guess, of the framework. And I'll go into that in detail also. And then, of course, there's the client-side part, which at this point, it's only a WPF application. Technically, I may do this in the future, but for now, in a completely different programming language, so the clients can be on completely different platforms, such as a mobile device, an iPhone, any iOS device, so to speak, an Android device, Windows Phone, or a Windows native application that can be developed in a different programming language, such as Delphi. And Delphi can then consume the REST service which sits in here. But for now, so you can run it on your local machine, I created a WPF application. Very, very, very simple, nothing complicated. And then the service part that the client will use to communicate to the REST-based service. And then the data transfer objects that the client then basically uses this information, these pieces of data, and then displays it on the client side in a WBF form. So let's just go ahead and run this. I'm going to press F5. I configure the solution to first kick off the service side, which is the server part of it. On the let me move this to the side here, which would by default be your Internet Explorer would kick off. And then the second solution, or the second project that kicks off, is the client side, the WPF application that communicates to the service, which just happened. So what just happened is the WPF application started, and it during the startup, I've programmed it so that it will communicate to the service right away, and it gets a list of objects, which in this case I only have 2 in here. And that's basically it. So there's a bunch of things that happens during this process, and we'll come back to the application, what happens. So let me just go ahead and shut this down. Stop it. So first, I'll go into the REST service here. And I started out creating this REST service with an empty Web API project. In Visual Studio 2013, it's already built in, which means you can create Web API service projects by default without having to worry about the add-on. In Visual Studio 2012, you have to make sure that your Web API Part 2 or Web API 2 is included in Visual Studio. You can download that if you Google it. If you don't have it in Visual Studio, you can just Google it and add it into Visual Studio. I think it's also available in NuGet, if I remember correctly. That's how I got it here. So anyway, here's the service. Actually, I should start really from the core, right? Because in a normal application, a normal system, no matter how large the system is, the core of your entire system really is really centered around your domain model. This is where everything is going to be controlled from the business point of view, meaning if you have certain rules that you need to apply during a certain process, what happens when, if you follow the money, so to speak, if you need to deal with financial information or any type of amount of money, follow the money, so to speak. And as you follow the money in the process, you'll find out what areas are being touched on in your domain. So no matter what industry you're in, the domain model will be your heart of your system. And so what I've usually done over the years is I start out with a core domain object class that has some very basic functionality. I have typically used the domain object to include also a name, because normally things in the real world have names. If it's just objects or even processes, usually things have names. So my domain object, usually I provide the option to give it a name. And if I do a simple, in Visual Studio, if you do a simple toString, I simply expose this name as my base class here. And I also usually put a version stamp inside my domain model so that this comes in handy later on. Hopefully I'll be able to show you that and what happens when you make changes to a domain model, what happens to versioning, especially in a cloud-based system, a cloud-based environment, when your system needs to be up 24/7, high volume throughputs. So a version stamp, simple string, will help you in dealing with this. I don't have a lot of things in here that I normally do in productions, but this is very basic, but it's important enough so that you can get an idea that this domain object will be a key player as you make changes in your system in the future and maintain it. The ID, is probably you've noticed that already, is automatically generated via GUID. This is important for two reasons. That you want the ID generation to be done inside a domain model and not dependent on any kind of persistence. The idea is that you design your domain model and so model the real process and objects in real life without ever worrying about what it's going to look like, how you're going to expose your domain model, or how you persist or store your information. So you design your domain model as you have an infinite amount of space available to store, and also you don't worry about how to expose this domain model, how it will look. So you just worry about capturing the process and the domain itself, so that you yourself as a developer will understand what the domain is all about. So you can talk the business language more, so to speak, so you understand what you're trying to capture in real life. So anyway, so this ID generation is going to be important later on. You don't see it here right now, but just remember that you want to have control over the unique ID generation on your domain model. This comes in play when certain replications or certain serializations of the objects later on in persistence, you want that full control of the ID and not have the persistence tell you what IDs you're going to have. So as you can see, there is no attributes on my domain class. It's a simple C# class. I have a simple timestamp that I usually use for many reasons. I want to know when an object has been created. And active, I usually use this as for logical deletes, so to speak, in a system. So sometimes you don't want to delete, but you just want to have it marked as hidden. So that can be very useful over time. So, and these are very simple properties, nothing to it. I use default. Sometimes if I have lookup objects or lists of objects, sometimes I want to know which one is a default object that I want to present somehow, either in a reporting layer and the user interface layer. This helps to sometimes also determine in certain processing of tasks or business logics. So sometimes a default helps you a lot doing that. And active, of course, sometimes you want to have the user being able to activate or deactivate certain features in your system. So this will help you with this simple Boolean. So yeah, overall, it's a very simple domain object. This will be the base class for everything in your domain class. I mean your domain model. Now I have a very simple domain object called person, and for now it's called person. I wanted to keep the hierarchy very, very simple. So just to show you the idea of the persistence in general. So I wanted to keep the domain model simple, but I will add more to the domain model over time to show you some more complex relationships, maybe embedded complex objects within objects, lists of objects, of course, and then maybe parent-child relationships, etc. Those kind of things where it can get really hard or hairy depending what persistence you're using. So for now, again, I'm overriding toString and present first and last name of the person class. So that's basically our domain model for now. And let's see, let's go into persistence. So yeah, which is the core, right? What we are trying to solve here, which is how do you now store this particular person, an instance of a person, into something that's permanent so that you can retrieve this information later on. Remember, this is running on the server side. If you have a cloud-based system, this would run on individual nodes and clusters, so that especially in cloud-based environments, or even traditional client-server applications or NTIA systems, but in cloud-based specifically, you don't want to have state. You have to deal with state on when or how you stored information, those kind of things. So, so keep that in mind. These server parts should be able to run on multiple nodes at the same time. So if I have a cluster of 10 nodes or 100 nodes, this should still be fine, right? and so which it is easily doable now. Anyway, so I guess that would be another good video screencast on how to take this into a cloud environment. Anyway, so let's just show the, I want to show the actual persistence idea. So one of the best features in .NET that came out in version 2, actually in .NET version 1, you had to do this by hand. You had to create these base classes by hand, but let's not get into that. But since .NET version 2 all the way to .NET 4.51, it is available. .NET itself uses the provider-based pattern since version 2, which is, I think, 2003, if I remember correctly. So it's like 11 years ago. So it is used all over the framework. You may not even know it, but you're using the provider pattern all over the place. And to my really big surprise, a lot of people are still not aware of the provider pattern, which is amazing. People are messing around with a repository pattern, which to me is almost a waste of time when you have the provider pattern right there in front of you, where the .NET framework can take care of so many things for you, built in the framework. So why not use it? I've used this pattern now for quite a few years, since it came out in 2003, so 11 years now, successfully for persistence. I've used this pattern for other parts. You can even use this provider pattern for additional features of your application, etc. So the idea is that this base class, as you can see, it's embedded in a system namespace. System.configuration seems kind of strange, but it's been put in the configuration for a reason. I'll show this to you later why it's in the configuration namespace. Anyways, this base class, let me open it up. I'm gonna go ahead and decompile it. Of course, I'll use ReSharper. Everybody should use that, by the way. The provider base class is actually an abstract class, but it has a bunch of things for you built in that you can use. So what I'm doing here is, and how this works, I'll show you. Since I know I want to have multiple persistence providers, not just one for an object database. In this case, I'm using DB4O, which is a fantastic object database for .NET, also available for Java. But I've been using DB4O for many years now. So later on, as I build out different persistence providers for Redis, for SimpleDB, which is a NoSQL solution from Amazon, and typical SQL Server, just to give you an idea how this works. These functions, these methods, basically are your entry point from the domain layer, right here, from your domain model down to the persistence. So just to make that clear, the persistence will never call up the layer into the domain model, right? And you don't want that. But the persistence layer is aware of the domain objects, aware of in a sense that from the persistence point of view, the domain objects are simple placeholders of data, because they don't, the persistence will never execute any behavior from the domain model. It will simply just know that it has to deal with a person object. That's it. What that means, I'll show you later also. I think this becomes clearer later on. So these are very generic at the moment. There's not a whole lot of methods in here, as you can see. But over time, in a larger system, you have quite a few of these, going down here. And that will be your generic interface into the persistence layer, right? So you can also use this. This is great for unit testing or functional tests, and then even replace your persistence provider maybe with an in-memory version of your persistence to have super fast functional tests available to you. So I have used this, for example, the generic save method for many, many years. The key point is that since you know that all your domain objects will come from your domain object base class, you want this in a generic form so that your queries will become a little bit easier on the implementation of the persistence providers. And I'll show you this in a DB4O provider first. So basically this save method can be used for anything you want to save in your entire system with one line of command. You can save the most complex object graph you have in your system over time. It doesn't matter. You will always be calling the save, which is very, very simple, right? Then, of course, there's a generic one I've been using. It's called delete by ID, because I know that every object in the domain model has an identifier. This is only for uniqueness inside the domain model. The identifiers is only for that purpose. It doesn't have a business meaning, right? So a delete by ID is for unique identification inside the domain model. So I'm not using like social security numbers for business reasons or business purposes and for unique identification inside the system. Something that you probably used to is maybe by email, because we know email usually are unique identifiers, right? Normally. There's some scenarios where this might not work, but normally email addresses are unique because the way the infrastructure is built on how to compose an email, right? How this would work. So we can assume that email addresses are unique normally. But besides that, I have a guaranteed uniqueness inside the domain model with my own identifier in the domain object class. Then, of course, I have getObject by ID. And then this little part here, load referenced objects, I'll show you this later in a different provider. Not in DB4O, but many other providers will need this. And I'll show you this later on, how this would make more sense and why this is used. So for normally its default setting is set to true, but it has no effect right now on the DB4O provider here. This becomes clear later on in the future. GetObjects is a very generic list. If I know I don't have a million objects to return, this will work fine. Let's say a small list of 100, a couple hundred, or thousands. So I don't know. It's, you know, as long as it's not like in the hundreds of thousands or millions of objects, this should work fine for most scenarios. No paging here, as you can see. Save objects, same idea. I wanna store an entire list of objects, and then get object by name, because I know that a lot of objects in my domain model are referred to by names, and then usually users are talking to your user interface, in this case the WPF application, maybe by name. Names are easier to remember for people than IDs. So anyways, so this is a very short list. This is your central entry point, your central interface into the persistence layer. Now, the way this works, because I'm deriving from the provider base class, actually I can show this real quick. This should work here in the help. If it doesn't take too long. I'm running this in a virtual machine here. Yeah, you can read about it basically if you click on the provider base class. It will give you some more information about it. But the functionality is for, it was originally born in ASP.NET. I forgot to mention this. I mean, it came out in .NET version 2. This was done originally for, I think, for the profile providers. A lot of parts of ASP.NET. This was coming out of the need for ASP.NET to have this provider pattern mechanism. So you can read more about this in your help. Anyway, so this is the key part, right? Inherit from the base class. What it will do is it will give you functionality so that it will automatically, when your system starts up, in this case the server layer itself, and it starts up, in this case maybe my service actually, it will automatically locate your assembly, the physical assembly that implements this interface here based on the configuration. And then it will pull in that assembly, it will instantiate that assembly, and then execute that code. And to demonstrate this, actually, here I can prove it to you. if you notice, in my server portion here, actually let's go into the REST service and the references. And you can take a look at this in the source code once you download it. If you notice, there is no reference. There's no reference to the DB4O provider. So there's no actual physical link on your REST service to the actual persistence implementation. The only reference we have is the generic persistence service, right? And that's important. The persistence service it's right here. Persistence service is this project, right? And persistence service is very generically implementing an abstract class. I mean, it's not implementing, but it includes this abstract base class to provider base, right? So again, there's no reference to DB4O. This will be your entry point into the persistence layer. Every provider will be deriving from this class, persistence provider class. So let me go back to the service here, references. So as you can see, no reference to DB4O, right? What I do need to do is, and I get into the details now here. Again, this is a web API, a REST-based project. If I go into the web config, so what I have done is I created a new section for persistence right here, right? And persistence service is the project that we just looked at that implements or provides the very generic interface. And then my only provider that I have at the moment is the DB4O provider, which is my object database. Now over time, this will be extended. This list will grow to more than one. I think the next one I will work on is the Redis provider, and then possibly the SQL, and then possibly a simple DB, which is a NoSQL storage. So by adding multiple providers in this section, I can simply change the provider. And here comes the power, right? I can change from an object database by simply changing the configuration, the default provider, to maybe the Redis provider. And I'm done. I didn't make any code changes. Absolutely no code changes, right? Simply change the configuration. And by doing that, I completely switched the provider. My persistence logic changed. So you'll see the benefit later on as we get down further in this series. So anyway, so here's the configuration. Let me just close this. All right, so I'll go into the service a little bit more later. So I think this is okay, right? Oh yeah, the persistence part. Here's something I've used also for many years. It provides you access to the providers in the provider collection. And there's two ways of doing this. Right now, the way of implementing it here is that all providers get loaded and instantiated. So you can actually switch the providers at runtime from a completely different object, from one type of persistence to another at runtime, by simply switching the provider using the provider collection over here and changing the provider at runtime. I don't have this as an example here, but for now I'm just using the default provider that's being loaded. I've done this also in the past where I don't want all providers to be instantiated. I just want one, whichever was the default provider that was configured, and that's what I'm using. That's what I'm using then to do my persistence. I will probably update the solution to do that. Right now, I haven't had time to do the changes. So for now, it will use the default provider and use that one. All right, so this is the persistence class, and you will use this persistence class to refer to the persistence. And here's the provider configuration section code. It allows us to have this section inside the web config file over here. right over here. Well, actually, it's this section, basically, in order to have this section, right? So I use the configuration section base class to do this. So very easy to do, just a few lines of code. And we basically have our persistence interface. So you'll be coming back to this piece of code over and over time. As you make changes, as you add, as the requirements change, you come back to this and trim and change and mold these methods over time. But this is a good set to start out with, a good base set of methods. So I'm going to leave this open for now. All right, so let's go into the nitty-gritty and the actual implementation on how you would store your objects, your C# objects in .NET. Again, so every provider will have to be implementing this interface, which is our persistence provider, right over here, right? So here I can do whatever I have to do to specifically do the persistence the way it's unique to this provider. In this case, I'm using DB4O, an object database. I highly recommend it. Been using it for many years. You can use DB4O probably for, my guess, easily 70% of your projects, even in enterprise environments, corporations, small to large. Absolutely no need to use SQL Server at all anymore today. Total overkill. DB4 is extremely powerful. It's available for Java and .NET. Check it out. Highly recommend it. It saves me ton of time to do fantastic persistence. And it's free. It's freely available. Anyway, so that's another video actually, just talking about DB4O and the power of it. I gave actually presentations about DB4O several years ago. You might want to go back to my blog and at thomasjaeger.wordpress.com and check it out. Anyways, so object container, if you're not familiar with DB4O, just ignore this stuff. I have a generic close, disconnect, connect. Remember, these methods came from over here, so I have to implement a connect, disconnect, save, those methods, right? And I'm going to go down a little bit further. Here's my generic save. Just try to remember when I come to this, especially to the SQL provider implementation. This save becomes extremely complicated in other providers. In DB4O, it is one line of command to store any type of object and then commit it. In DB4O, every save or every commit, is an ACID transaction actually. So it's amazing. No matter how complex your object graphs are, how deep your object graphs are, it is one line of command in DB4O, which is object container.store and then your object. That's it. Cannot get any simpler. That's why I started out with DB4O, is because it's the easiest and simplest way to persist your objects. It's super simple. My delete by method. Now in DB4O, I've created a generic object facade. And I know that, remember, I have domain objects always in my base classes. So I know that every object will have an identifier included. So I'll go into the object facade in a little bit. So as you can see, most of the stuff is one-liners. Just a couple lines here for saving my list. And then even getting object by name. Now DB4O has multiple ways to query out of an object database. One of them, of course, is link. You can do simple link queries like this and get your objects out of the database. You can do 2 or 3 other ways to improve performance actually, such as query by example or query by objects examples. There's another way, I've just forgot right now, but I've gotten used to using link for now because I can take that link query, for example, and use it in Redis almost with no changes, actually, which is amazing. So anyway, so this is unique to DB4O. That's it. So just as you can see, a few lines of code. Check it out, run it, get the code. So the entire provider is very, very simple, very short. This will look differently for SQL and other providers. It will not look as simple as this. The key is that we are staying to this interface. That is very, very important. You stay consistent. You make a change here, you need to update your providers to be consistent. Okay? All right, so you got a DB4 provider. You got our generic interface into persistence. I've talked about that. I've talked about the domain model. That changes over time. Let's go into the service. So I really only have one controller because I'll have a simple, let me close this down, a simple person class here, right? Oops, DB4. Let me show you again the person class. Right here, because I'll need this as a reference later on. All right, so person class and the person controller. So one thing that you can do is in the Web API 2 for Visual Studio, when you add, let's see, I'm pointing to here, the controllers. So I click on the controllers, and then you can do an add. See right here, Web API controller class version 2. If you click that, that's when you kick in the new edition in Visual Studio 2012. In 2013 Visual Studio, it's already built in, so it's, you don't have to worry about that. All right, so that's how I created my controller, my person controller initially. So I basically deleted everything, practically almost everything. Actually, let's just show this, since I'm doing the video here. Version 2, we just leave it like this. Value controller 1. And it will show you an example controller. Now we don't want it like this because we want even a simpler way to an attribute-based controller. So let me delete this. Actually undo it, huh? I just delete it. All right. So since this is a Web API version 2 controller, I want to use the features that came out on Web API 2, which was really attribute-based routing, which is super simple. It's very, very convenient. I really like it a lot for quite a while now. Before version 2 came out, there were some third-party solutions available, and I'm really glad that Microsoft put the attribute-based routing inside the Web API, which is really cool. All right, so we have a generic get with no parameters over here, which means I want to get a list of people, a list of persons. I know it's not correct English, but that's another thing. When you stay with multiples or plurals, don't do people. Leave it with stay consistent with plural. So you know, when you have a controller, you're always dealing with more than one. So stay plural, persons, right? Because you can have multiple persons inside the controller. If I had a controller for Apple, I would have apples. So stay consistent with plural. I use a V1 convention for versioning. Each controller has its own version this way. This becomes important as you upgrade and change the system over time, especially in the cloud domain again. And then, of course, you don't want to change existing interfaces once these are exposed to the public, right? So you should have version in your route prefix. And then I use a default API, which is fine. There's no harm. And my default action for this class, for this person controller, is a get, right? So if I don't specify an HTTP method, it will be the get action by default. And the get action by default will be this. with no parameters or no identifiers or no unique ways to get specific information. It will give me basically a list of all the people. And I'll go into detail here with the application facade. That's my entry point throughout the rest of the service project. And if I wanted to have certain logic inside my service, like pre-processing, filtering, validations, logging, exception handling, etc., those kind of things, I'm going through an application facade, which is a singleton, to get all people. And eventually the application facade will go dig down into the persistence to grab the actual objects. And then I'm using something else called AutoMapper. It's a fantastic tool, highly recommended. It allows you to map your domain object into a data transfer object. So this way you're saved from manually mapping each property from one object to the next object, which is very, very boring stuff. You don't want to do that by hand if you can automate it. See, in AutoMapper, I can do the entire person object. This case only have 3 properties, right? First name, last name, and email. It will do this in one line of command to map the projects from my domain object into my DTO object. Let's go link in there. Look inside. My model for the service, or the models for the service, are in the models folder. And I only have one here right now. And it's very similar to the domain object, but don't be fooled though. The concept of data transfer objects is also a fairly big subject. This is just to provide a way to expose your data, not behavior, right? Because we're dealing now with pure data pieces, your data to the service, to the rest of the world. So these data transfer objects might collect information from multiple domain objects to combine it into one DTO. You might want to expose, if I had a very complex person object, let's say I have actually, in some systems I had, these person objects can be very, very complex, very large, one of the largest objects basically in your system. That can have like dozens and dozens of properties and behavior built in, right? And maybe you don't want the entire array of objects exposed, so your DTO maybe will be a very simple one, maybe with an ID and maybe with a name, right? So it can be a very simple representation of your domain information. So these DTOs usually are different, slightly different than the domain model, and sometimes extremely different from the domain objects. So keep that in mind. So so I'm mapping the domain model, the person domain object into my DTO. And then I do a simple create response, which is a one-liner, as you can see, very convenient. And I'll show you there's another way of doing it later. If I go scroll down here, it gives me status code of OK, and then the actual list, which is the generic list of people, as a JSON format. Something very similar with an ID. If you pass the ID in a controller, if the consumer would pass the ID, you would get a specific resource, which would be the person with that ID matching, right? And this is where I get my object by the ID. That would be the unique identifier as a string and return it. If it doesn't find it, I will generate a not found. I think it's a 404, right? I don't remember now. Is it 404? Yeah, it's a 404, yeah. And then return the response if it's successful or not. Now for post, if I create a new domain object, then I'm expecting a complex object, which is a JSON. Now Web API, ASP.NET Web API will then basically do the automatic conversion, basically the deserialization of the JSON object into my DTO object. This is done behind the scenes. You don't have to worry about that, which is a great thing. Actually saves a ton of time. And so out comes the the JSON string, populate it and instantiate it into a DTO object, which is, again, it's this one, right? So one of the things I have to do is, and this is where I go a little bit more detail, is I need to validate there's different ways of validating information coming in, right? There's another way of validating information before the controllers even get executed. It's a little bit more complicated, but I didn't see having a value here right now, especially as an example, to do attribute-based validation and have doing it that way. I like the convenience that I'm inside the controller. I know exactly what happens, and I just want to validate it before I continue processing this request. In this case, creation of a new person. And so I'll go later into this error code mapping and the response back to the user. So I'm doing a bunch of validations here. And then, of course, I know that the ID, the user might even pass me an ID, right? The client itself could pass me an ID, but I know that this is a creation request. So for now, our rule says, well, in this case, in this example, that I will ignore the ID. Remember, the ID I want to have full control over in a domain model. I don't want the client to tell me which ID I need to use. This becomes again important, that you must have that control of the ID generation and maintaining it. So you should not use that ID during a post coming in. So what I'll do is instead, for example, this could be a business rule, right? For processing an incoming creation request. So I know that your email is unique. I can query by that. I can query my persistence. And of course, if it exists, then I'll let the user know that's an invalid request. If it does not exist, I have simply created. And there could be certain rules that need to apply before you need to create this object. So I'll pass it in, create the object. And when it's created or not, I'll let the user know. For now, I'm just going to send back the actual created object as a DTO back to the user. You can also send back the URI, the URL link to the created resource. Also, there's another way of doing it. And I actually like sending back the objects, but some prefer just a link, the URL to the created resource, which I think is the correct way of doing it. I'm not sure. I think it is. So for now, we'll just leave it as a JSON. If I want to update a person, I need to know, of course, the ID by passing the ID in. Right now, I'm forcing that I have an ID, but technically, you can update by just sending me a DTO, and then I can grab the ID that comes out of the DTO. But it is common practice that we pass the ID in and then verify this ID. And I'm using, let's see, the ID to look it up. And if it can find it, great. Or if it cannot find it, I'll let the user know that it's error response. And then finally, I actually do a real delete for now, for an example. In other applications or systems, I'm doing a logical delete usually. Even though I do a delete HTTP method, just marking, remember, our domain object has an active boolean, and I can just mark it as false, and then logically delete it this way, and then store it in persistence. But here I'm actually executing the application delete, and you can actually hide this behavior inside the application facade. So the controller doesn't even know, hey, I'm just want to serve the delete request. So yeah, so that's this service controller here. Let's go into the application facade. So here I'm doing some basic validation. For example, if you noticed, if I create a new object here, let's see, I think, oh yeah, here I'm doing this. I'm actually validating the email inside a DTO if this is even a correct email. And let's say we have a business rule that we do not allow junk emails, or that are not look like real emails. So at least we can do some kind of validation as a minimum. So in my application facade, over here is really your central point where you can go to, from a controller point of view, into a central point inside your service project on how to continue with this request. Should the request be served, right? And passed along potentially, if necessary, throughout your system, throughout the layers. So I have here a simple email match pattern for regular expression that I've been using for a while. Actually, works really well. And I've even commented out you can do initializations here. For example, this will probably change over time too. I might be adding logging, maybe even a cloud-based logging mechanism. This becomes even important when you have many clusters. Many nodes running, but things happen and things go wrong, and you need to log information. So I'll probably demonstrate also in the future how to do this, possibly into SimpleDB. It's a fantastic way to log information. Anyways, you can do the stuff in here. And here, basically, oh yeah, remember, create person. Let's follow through here from the post, right? So I have get the person, and I didn't find it, let's assume. And I'm gonna go end up in here, which is create person. So I'll pass my DTO. I'm still inside the service. And now I'm gonna map, which is a fantastic tool again, right? Otherwise I have to do each property one at a time. I'm taking my DTO and mapping it straight into a brand new domain object. This is a brand new object, it doesn't exist yet. Now, one thing you've probably noticed, I'll come back to that in a second. Once my domain object is created, remember I have a generic save, and I know right now I'm using db4o, and it stores this domain object in with db4o locally, then on the disk for the server. That's it. Now I just completely persisted. This could have been a very complex domain object. It wouldn't matter. I still have a save, very generic save method. That's all you have to do. Super simple. Now, what you might not see is, remember that as I said earlier, the ID generation, we need to have control over that. Only domain model is allowed to deal with generation of the IDs here, right? Which happens here. So what happens with the mapper, auto mapper, what it will do is, by default, if you don't make changes, it actually maps whatever came in from the DTO here, which is including the ID. If this ID would be null or empty, it will actually create its domain object with an empty ID, which you don't want, right? We have to guarantee that the IDs are unique. And so what I had to do, because I'm using AutoMapper, I'm going to go into the configuration, actually the global section of your service. I had to tell AutoMapper to basically ignore the property called ID in my destination, which is my domain object. So when I do the auto mapping, ignore the ID property, basically. That's what I had to tell AutoMapper. This way it will ignore it, right? You can see this in my comment here as well. And because I'm ignoring it now, what happens is, because it's the mapper, the AutoMapper portion will create and instantiate a new person object. And because my, where's my domain? Oh, here. Because by default, when I instantiate my person object, which derives from my domain object, it will automatically generate the unique ID for me, which is a GUID, right? It will guarantee that this ID is unique because it's instantiating it by default with this ID. All right, so I'm all good then. And then I save this person. update method, it's actually similar. Here, unfortunately, I had to do the manual mapping. When I update an existing person, I'll pass it in over here. Let's see. Right. So when I do an update, I'm getting the person first. It's loaded in memory on a server. I have a reference to the object, and then I'm passing it into the application facade. Same person, right? And I'm mapping the project, the properties. I think there's another way of doing it with a mapping automapper, but for some reason, first I tried the automapper part, but I couldn't get it to work for now. So for now, I'm just manually mapping it back, which should be okay. Delete account, very straightforward. It passes along the deletion of the person by ID, but this time from the persistence. Validate is the actual logic I'm using here for validating the email when you create a new person. So it just kicks off the regular expression with the pattern that I have up here. And that's it. So again, application facade is very simple. Usually this will grow over time, of course. It will have a lot of logic in here in terms of validation. Well, a lot of validation basically stuff could be stored here. Logging, exception handling, those kind of things, right? Security is another portion. That's another way of how do you add security to controllers. That's another topic actually to talk about. Let's go look at the error map. I remember what I had earlier in the, let's close the facade. Over here, when I needed to create an error response to the user from the controller. It is highly recommended that you don't send back a generic 404 if your logic in your domain layer already knows that something went wrong. It has nothing to do with an HTTP transport or the HTTP methods. They're somewhat limited because your business requirements are very unique to the business that you're in and the solution that you're trying to create. So they're very unlikely to be able to map to the generic HTTP error codes. And this works really well when you have a specific list of error codes and then very generic error code types that you can then spit out or respond back to the clients. This list will grow over time. There's other ways of doing it, but for now it's just very, very simple to use. And it's very informative, and I'll show you this later in an error, what it looks like on the client side. This message actually gets then delivered to the client consumer, or the consuming side of this service. You want to be very descriptive. What happened in your system if something goes wrong. This is very, very important in a service-based API that you want to expose. So your error codes become very important. It's an important tool in helping developers on using your API or any client for that matter. So I only have a handful in here, but the very generic ones. You can use this to start out with and then build upon these error codes. But at the very end, it will come back with an HTTP response message, right? That's what your controller will look for over here, essentially, right? And so the great thing about using the numbers is you can tell your consumers of your API that what this number specifically means. You can have a lot of detailed documentation or description about this error code, and not just a one-liner like here. It will help out at the beginning, for the developer to see, okay, first name is required, right? But let's see, I have also a description where you can add additional information about the exception, quite a bit more actually if you wanted to. And so I have a very generic error response class for that purpose created. So it has always an error code in int. Then the type of the message is a string, the message, and a description. You can also add an array of error codes or an array of error error messages or error data. If you have multiple validations that failed, this can be built out further. So they live right here, the error code types. I have unclassified invalid request. This will be probably your most common one used. It matches quite a few actually error conditions. And then sometimes if you deprecate things or add things or an invalid call, features are unavailable. Security parts, if you had security in it. I just left it in here for now. And then of course resource not found. And then generic service errors and session errors. Session timeout not directly meant the typical sense, more sessions on a server if you have those conditions. So I left these generic error code types in here for you. Excuse me. Error response, I already talked about that one. Okay, I think I touched on most pieces. There's nothing visually here in the service, but I've talked about here. And then let's talk about the client side. So I think I'm done with the server side, right? For now. So let's again. Do you remember right here? I had in my model I had a person DTO, right? On the server side. Now I could have created a generic project called maybe DTOs, and then share this project between my server or my service implementation and my client, right? Because I'm using also a person DTO on my client side. The reason I didn't want to share it is because that doesn't really reflect the real world scenarios on when you actually do this in real production environments. Normally, or many times, you're just a service creator. You're the guy who maintains the API, maybe an API that's exposed in a cloud environment. But then you have many clients that using your API, right? So you're not really in control of both parts on the client side and the server side. If you are great, then yeah, you can share these DTOs across. But even then, I would not recommend doing it. I actually would recommend doing it separately, not sharing these DTOs, because these DTOs are specific to the use cases, right? The DTO here that I'm using for the client is tailored for the UI that I'm exposing these pieces of information from. Really, it could be identical to what I have on my server side, but it could not. You could actually combine on the client side. I can have a different type of or different kind of view to look at this data than I have on the server side. On the server side, I have it's a simple representation already enough for my domain object person, right? So like this. But over time, on my client side, you could have many different types of DTOs, maybe an address DTO or something that's related to this person, maybe as an employee, where I pull in different pieces of information, but I want to deal with this as one class. So therefore, this DTO lives only on this client side, C#. As you can see, even my toString, as an example, I just changed it a little bit. If I do in my binding on my WPF, by default, it will use the toString representation of an object, and you'll see that in the UI. It will just use this one then. This, of course, has nothing to do with my DTO on the server side. No need for that. Absolutely no need, right? Maybe for report generation. I can see that happening on the server side. If you need to generate in your service layer, I mean in your reporting layer, that this particular person could be exposed inside a PDF report, right, on an HTML report, then maybe I can use a toString representation of this DTO. If I haven't mentioned this yet, the domain objects, by the way, they never ever leave out of the domain model. They always stay in here. You never directly pass them along and use them somewhere else, other than for example, for the persistent side, right, where I just need to store this this object as a serialized form in some form. Normally I'll deal with DTOs. Your data transfer objects will become very important. The DTOs will become your best buddy, so to speak. So get familiar with the AutoMapper tool that I've showed you. It will help you try quite a lot. It will keep the code simple and clean, and you'll be actually a more productive developer. Anyway, so I have my DTO base class. For now, there's nothing in it. I thought there was a reason why I did that. I can't remember now. Anyway, so I have a person DTO on my client side for my UI. Let me expand these here. On the WPF side, let me close this down. Alright, so as I mentioned earlier about the DTOs, the same thing applies to your error mapping. Normally the consumers of your service may not be you, so they have their own mapping probably, or how they want to represent these error messages to the UI. Maybe they want to give them a more user-friendly message, a more descriptive explanation, or maybe not. Even maybe they just want to ignore these errors and handle it differently. So the error mapping on the client side looks similar right now, right? I only did this so that actually let me close this out. It looks like I'm duplicating it, right? Which I did. But on a normal real-world scenario, they have their own representation of these errors coming from the service. So I just did this so it looks very similar. There's a rarity. So you can take a look at that once you check out the solution. You can change it. So I have a REST services class. That's my, and of course, normally you would put this in a configuration file, right? This kind of stuff. But that would be my entry point from the client side to the service that I'm exposing, right? I have an error info class, and this is the error that will be populating, or this class will be populated, or this object actually will be populated. And if there are any errors on the server side, this will be the object I'm going to investigate on the client side to do further processing on that. And then usually I want to know if it was successful with a warning, a failure, or unsupported. It's good enough for the actual result of a service call. Remember, this is dealing with a REST service here. And then I usually have something like a list of acceptable HTTP response codes that I think, or from the business point of view, are acceptable. And by default, of course, there's the HTTP OK 200 and 201. You may have other ones that you want to add here, but that's my acceptable response codes. And let's see. All right, so now we're already hitting the parts where the client will call. Actually, let's start this up like so. All right, what happened here is, before I click any of these buttons, let me go switch over here. So when this WPF application starts up, where is my, oh, let me go back to the, if you noticed, I even have an application facade inside my WPF application. That's, again, it's just like similar to the service side, on the server side, application facade. That's my central point where I can run to, so to speak, where I can do further processing, pass along things, requests, messages, so the application facade knows what to do with it. If there are subsystems it has to deal with. So in this case, if I look inside the WPF code, if you noticed, I have a generic update UI, And then I set the focus to the first name text box. But this is the part that I wanted to show you, update UI. So the first time the application starts, the WPF Windows application, it talks to the application facade. It gets instantiated. It's a static method here. I was going to say singleton. Normally it's a singleton too, actually. But I know it's I only need one instance for this, so I'm using a static method. So as soon as the application starts up, no UI is shown yet actually. This you can do normally in a background thread, of course, and not to block the main UI thread. For demo purposes, this was good enough. So it goes to my application facade, get all people, and it then passes it to my REST service. In here. And now in the REST service, normally what I do is I always pass back what's expected on the client side and then deal on the UI later. If it's an empty list, it's more user friendly than having a null object always generate and causing problems. And then I need to track, but I just simply return an empty list if something happens for some reason. And so my get list method, remember I'm in the service class now. Let's go to get list. This is a very generic method to communicate to an HTTP endpoint using the HTTP client. And there's some other things that you normally probably would set here, which is the authorization headers, tokens, such things, that normally you have to set. You can set them right in here, which I normally do here. If it is a WPF or Windows, a .NET Windows application, by the way, it could be a completely different client, and it's of course a different story. But anyway, so you can do the setting the security headers here. And what you want is you want the result from the service as a JSON payload. I want to make sure that the resource is destroyed after the request is done. So I'm using, and then the the URL to the endpoint executed. It's a blocking call for now, and I will get back a JSON result. Because I'm handling the errors and exceptions on the server side, I should always get some kind of JSON result back. And then basically I have a method here, the handle response. And handle response basically allows me to validate if there was a problem, right? So if it's not in one of my successful response codes, then I know, hey, that was an error. Something went wrong, basically. Now, right now, I only have two. Remember, we had the OK and the created one. So it's an HTTP 200 and 201. Everything else is considered an error, an exception. I need to deal with it basically somehow. Again, you would do your logging in here too, which I took out normally, but I will probably add this in later. And then I deserialize using, of course, the fantastic JSON.NET library, which is built in, by the way, in the Web API now, Web API for Microsoft. In the solution here, I have it as a NuGet package, and you should get this automatically then when you compile, when you rebuild a solution. So I'm basically handling the error here. And then, let's see, go back. So remember, I'm getting all people, right? I'm handling the response, and I'm deserializing now at this point, hopefully a list of the people, well, a list of person objects, right? And remember, if it was an error, this will be null anyways, and I can show you here. Get all people right there. So there you go. I should get a list, right? And it'll probably be an empty list if there's a problem. If not, if there's an exception during this entire process, I handle it in handle errors method. right there. The reason why I didn't put it into the generic ones, like here, the reason why I didn't put an exception handler here is because, remember, this is used generically. And because I know that normally in a certain environment, I mean, in real world scenarios, I want to deal with this exception specifically if there's a problem. So you could add specific logging or handling of an exception because I know, hey, I want to try to get all the people. Maybe there may be business rules I need to handle if there's something goes wrong, because I want to know if there's something goes wrong in this scenario only, and not maybe doing creation of a person. Then I can handle it here very nicely. So I want this generic list be let alone to be generic. If an exception happens here, it bubbles up to anyways to this exception handler here. All right, so and then similar, it's working for the create person. So I have one for post. Looks very similar actually. Not quite the same, but it's a little bit different. And for put, simply because I'm using different methods to execute. This can be generalized, of course, if this is always the same, but for now I left it like this. It's easy to see. One for delete, and then how to handle responses back, including the exceptions. Save, delete person. So as you can see, it's a very simple code. It's very straightforward. It's easy to maintain, easy to test. It's not a whole lot of complicated code in here. Very straightforward. It works really well. Keep it simple. All right, so this is the part where the client, then the WPF piece, communicates to the service. I guess the most complicated piece really in this WPF application is when you create a person. Remember, I have a first name text box, a last name text box, and an email text box, and those three get passed into the application facade as 3 strings. I'm validating because I don't want to bother calling a service and all that and get back an error response. I could do that, but why not just do simple validations on the client side, right? This is one of the things you should be doing. Simple data validations that is required before, because the service might come back with an exception. So it makes sense to have these simple validations here. No complicated business rules, of course, never ever on a client side, but simple data validations before you send it off to a service, yes. Because the service might tell you, hey, this is required field, these are required fields, I cannot process any further. All right, so I validated that I have 3 strings with something in it. I now create my person DTL, populate it, call my service, and here's the code very clean at this point, right? If I know that my service is successful, I can let the user know, and if not, I can handle the exception. For now, in this case, I just throw up a message box with the error info object. Remember what I showed earlier? And then it's populated, and I'll show the exception that came from the service directly. You might want to log this on the client side or not, depending how you want to handle your exceptions if something goes wrong. Maybe you want to give the user another way of creating a person or a different method, etc. But this, keep in mind, as long as you keep your exceptions and results in mind, you always cover your pretty much most scenarios. So don't just go for a happy path. Keep the exceptions in mind and the things that can go wrong. Very important. Save person, very similar. I should explain this part, DTO, because where does this DTO created, right? Where did it come from? So when you go back into the WPF, so in this sample application here, I have a list of 2 people, right? 2 people in here. When it starts up, that's because my I have the database actually. It's 4 or 5 kilobytes large. It's not very large. This is a DB4O file database. If you kill that database, it will be empty, and this list will be empty. So when this application starts up, it will get all the people, which I have 2 objects in here, right? But if you notice, this list is the DTO representation of the data. And remember, the DTO here on the client side is very similar to what the server looks like, server representation. So I have 2 objects in here. So now I'm dealing with these DTOs that are already populated, right? So if I hit the save click or the save button, all I'm doing is I'm passing it I'm assigning the values from the text boxes to my currently selected DTO object on my UI, update them, and then I pass this DTO back to my facade, right? So that's how this DTO got populated and comes into the save method. And of course I do a simple validation just in case, right? You never know. I'm calling the service, save now this DTO, and we're good to go. This could be an async call. And then you can have a generic, instead of having this code down here, an asynchronous call, fire and forget, and then get notified on the client side at some point when the service comes back. This is an example, so you can do it a little differently here. But essentially, you want to check if the service was successful, a service call. And if not, handle the exceptions. Same thing for delete. All right, so I think this is actually showing that's pretty much the entire client side, as you can see. Besides the assigning of the values, there's not much going on here. So if for example, let's try this. Remember, my service still runs, right? It's running in the background. As you can see, it's running on my right here on my local machine. So if let's say, so I got some bunch of data in here. So I just hit the create button by accident, right? I hit create. So what just happened is the UI sends this information, creates a DTO, sends it to the service, and the service says, well, it checked on the email, I already have it in here. The object already exists, right? So, and then on UI it comes back, I should simply show the exception. And if I save it, update was successful, right? If I force it, yeah, nothing changed because I haven't changed anything visually. So if I say 2, save it, as you can see, I'm automatically loading the objects back. These objects that you see here, they came back from the service. Normally, of course, you just update that particular object if you need to, get the whole list. So, but for demo purposes, I wanted to have the UI see any changes automatically. All right, so I have this. Let's just change it back. Save it, right? Let's delete. Let's delete this one, and let's delete it. Physically delete it. So what just happened is I send a request to the service. Let's just show it to you in case you forgot. It's been almost done with this demo here, so hopefully you liked it. So the request all the way goes down to from the server side, from the service, all the way to the assistance into my DB4O provider. And I have a delete right here. Oh yeah, I forgot actually. I wanted to show you what the object facade does. So the object facade, because I know I'm dealing with an object database, I put this in here inside the DB4 provider. It's a very generic way to deal with common behaviors. I mean, not behaviors, but the CRUD work of an object database. So delete by ID, get by ID, get by name, and get all objects. These are unique to DB4O. Actually, not DB4, but these are very generic, actually. Oh yeah, it is. It is DB4 generic. Yeah, that's right, because of the querying I'm doing. That's right. So anyway, so that's the object facade, and I can use this. Let's say if I say a specific domain object, such as let's pick a table. If I have a table object, get table by ID, I could do it that way, right? And I can say I have a table object. This will still work. I can use my generic object facade to do it this way. Saves me some lines of code. That's why I really did it. Nothing to it. So let's go back to the client. All right, so I think I've touched on all the parts so far. Again, so now technically, let's just close this out. The client side could be represent. The client could even be another. It could be a website, actually, right? An ASP.NET web application consuming your service. It doesn't have to be a client-side app. The client could also be a completely different client, such as an iPhone, a Delphi application, a native Windows application written in Delphi, consuming your service. So there's many ways your service could be consumed. So the client side will probably change. So I wanted really to be concentrating on the persistence part. And so in the next few posts or videos, I will show more regarding the persistence side here. And hopefully you like this video, the screencast. And if you do, let me know. Please go to my website, to my blog. It's actually near me. I even forgot to. Anyways, yeah, it's Thomas. I should spell my own name. Yep. So it's thomasjaeger.wordpress.com. Go to my blog. Let me know what you think. Hopefully you like this. And I will try to keep the solution up to date over time when I have time available here and there, of course. And if you need help with your projects, I'm available as a consultant also. Feel free to contact me anytime. If you need help with architectural work, programming work, cloud-based systems especially. I've been working with AWS since it was in beta in 2006. Yeah, it's been 8 years now, and I absolutely love Amazon AWS services, and a combination of .NET backend for small to large systems running on AWS is a fantastic solution, or fantastic ways of doing it. So let me know, and thank you. See you next time.